what do we need to do first on here? Get rid of the 2. How do I get rid of that 2? Divide. I'm going to divide both sides by 2 because that's going to make this guy go away. Our whole goal on this first step is to isolate that absolute value. We need that by itself before I can do anything else. So if I divide both sides by 2, that's going to give me our absolute value of 6x minus 2 equals 4. Ooh, those are really far away. Let's scooch that up closer. There we go. So I don't need all my space. Then what are we going to need to do? We can't add 2 right now because they're still in that jail cell. They're still isolated.
Like separate?
We got to split them up. I have 2 options. 6x minus 2 is 4 steps from 0. That means 6x minus 2, that whole middle bit, might exactly equal 4. It is 4 steps from 0. It might just be at 4. Totally cool. But there's another option. My 6x minus 2 might be at negative 4. That is still 4 steps from 0. So I have more than one option. So we need to make sure we get both answers, and that's how we do so. We need to split that up. Now we can solve each of these. Now what do we do to get x by itself over here? And now we're going to add that too. You're just a half a step ahead. That's totally cool. It happens. On this one, we're going to get our 6x equals 4 plus 2 gives me 6. One last step on this one. How do I get my x by itself? Divide. We're going to divide by 6. So those guys cancel out. So what does my x equal? What is 6 divided by 6? 1. My x equals 1. And we could take that up into our absolute value and check it, because we do want to check that. It does check. I'm just going to give us that one. It checks. We did great. Y'all did awesome. But then we get to do the whole thing again on the right-hand side. But we've already figured out what steps we're going to take, and they should always be the same because this piece doesn't change. It's only this guy. So we're still going to add 2, and then we're going to divide by 6. It's the exact same steps. With the correct pen would be great. So the thing that's going to be different is the number on this side, but the steps over here are still exactly the same. So now we're going to get that our 6x equals negative 4 plus 2, which is going to give us a negative 2. Still aiming to get this x by itself, we need to divide by our 6. So what's our x going to be? What's our answer? What is negative 2 divided by 6? I was like, you flipped it. Careful.
Oh, yeah.
Negative 1/3. You can have it as 2/6. Like, that's okay. If you type negative 2 divided by 3 in the calculator, it should spit out negative 1/3. But you can also write it as negative 2/6. I am okay if we do not simplify our fractions. Like, you've done the hard part. And again, this one will check. Yep, it will. Which we should always do, but I don't want us to take our time to type those in. So we're supposed to check. These do check. I'm just going to give us that. We did the hard part. Okay? Questions on this one? Because we are going to move on away from absolute values. Yay! We're going to go talk about lines instead. Woohoo! So we're going to be in your note packet, page 6. Looks kind of like this. Piece. It's page 6. There's a number 6 at the bottom corner. Yes, dear. Okay, just double checking before I start working. All right, so we're going to be looking at some linear equations because as we get further into this chapter, going to do some kind of weird stuff with our lines. So we have a few different ways we can write equations for lines. And there's two that we have seen most frequently and one that we're going to work with a lot later this week. And that is our slope-intercept form. We know that one a lot. We've worked with this one a bunch. This one is our y equals mx plus b. What does the m stand for again? Slope. And what does the b stand for? Our y-intercept. It's a very specific piece. It's our y-intercept. So m is our slope, b is our y-intercept. So it uses a very, very specific point. Standard form has been a lot of ways that equations are given to us. It's not going to be something we use tons, but it's good to know. And that's when I have a times our x. So some number x and usually a different number times y equals some constant. When we have numbers or an equation that looks like this, it's in our standard form, sometimes called general form. Honestly, most of the time we use this is when we're trying to graph with x and y intercepts. It's not a humongo deal. We're not really going to take things from slope-intercept form and put them in standard form because it's honestly easier to find our intercepts in standard form anyway. So, there's not any times that putting it into standard form are particularly helpful. But it's good to know that it has a name. Awesome sauce. Our last one is called point-slope form. It's really kind of similar to slope-intercept form. It looks really crazy, and I promise we're going to work with it in a couple, I think tomorrow is when we start working with it, but, it looks weird. So our point-slope form, I just want to make sure I write everything down correctly. We say y minus y1. We put a little baby 1 beneath it. Equals m times the quantity x minus x1. So the x and y that do not have the little baby numbers are the normal x and y that we're used to seeing in the equation. They're the ones that stay there. The ones that have those little numbers are a specific point. So this is for any point on your line. Let me say it's x1, comma, y1. And then there's another piece we see in here that's familiar. M. And that's our same m, our same slope. So it is kind of the basis on where the slope-intercept form came from, because if we have a y-intercept, when we substitute that in, we're going to get our slope-intercept form. We are going to work with point-slope form more in a little bit, but we're going to start today working with our slope-intercept form and practice scooting things around into it, because it's a place we kind of struggled with before. But these are our three forms that we're going to see in lines most frequently. Again, when we're trying to look at graphing, we're not going to see very many like this. The only time we're really going to write equations like this is when we get story problems, and in which case we're usually going to try and solve it back into this thing anyway. So, it's a choice. So we're going to start by looking at slope-intercept form. So this little paragraph is there on your page, is right there. And it's talking about our slope-intercept, our y equals mx plus b, that same exact formula we just wrote down, this guy right here, where m is the slope and b was the y-intercept. Those pieces are right there. Oh, snap. And they even give you a picture helping us remember our slope that we typically write as rise over run. So that's up here remembering. And this little picture over here, it's really hard to see on the copies, and I get that. But they're showing you that our rise of 2 and our run of 3, looking at this slope of 2/3, we can see that from the graph if we take points that are on kind of tidy intersections. That's what they're counting from. They're counting from one point that we can tell is on an intersection to the next point on an intersection. So this is kind of just a real quick refresh on how to read a graph to see if we can find these pieces. Mostly what we're going to be doing is we're going to be taking equations and we're going to put them into slope-intercept form. This is going to be something we're going to need to be able to do, is take an equation in any form and put it into slope-intercept form. So we want this to be slope-intercept form, which means I want this to be a y equals mx plus b. We need it to be a y equals mx plus b. What that means is I need to take my 12x minus 14y, or minus 4y equals 24, and I need to make this be a y equals. I'm going to rewrite this equation just because it is super tiny right here. Holy cow. What? That way. Thank you. So if I want to take my 12x minus 4y equals 24, and we want to get this to be a y equals, what do we need to do? How can I get my y all by itself? So that's what I want. I want this guy to be all by himself like this one. What needs to leave where the y is? That, right? He's on the wrong side. He needs to be on this side. I want my x's on the opposite side of the equal sign. They don't get to be on the same team. Too much powerhouse. Too much power. I gotta get the x away from the y. They are too close when they're together. They cause problems. So since I have just a 12x sitting over here, what we're going to do is we are going to subtract 12x from this side. I don't want them over here. They are too strong when they team up together on the same side of the equal sign. No bueno. I don't want them together. So I'm going to subtract 12x from this side. I picked that because that's going to make these 12x's go away. They're going to the other side of my equal sign. So we're going to be left with our minus 4y. We got to keep that minus sign there. And that's going to equal, can I combine together my 24 and my minus 12x? Can I combine those as like terms? No, because they're not like terms. The 24 doesn't have an x. So I could put 24 minus 12x. Totally valid. If we think about our form over here, we really like having our x as the line leader.
Somebody at the door.
They were not knocking like they meant it. Okay, so I can't combine them together. I could put the 24 minus 12x, but since we usually like to have our x's in the front, I'm just gonna like squish him in. So I'm gonna write this as minus 12x. And then since that 24 is positive, I'm just going to put plus 24. Again, you don't have to do that part, but then we have to think really hard about which one is M and which one is B. It's totally valid. I just think it's easiest if we squish them in right there. We're getting better. We got our x's and y's on separate sides of the equal sign now. But I still want to get my y by itself. That is a very dark highlighter. What can I do to get my y by himself now? Oh, I heard it. It was quiet, but it was there. We need to divide by -4. I need to divide this piece by -4. And you can do it in two ways when you think about it. You can either divide this whole side by -4. If you like that, go for it, but you are going to have to simplify both fractions. I do think it's easier if we divide this piece by -4 and we divide this piece by -4. You can do it either way. As one big, I divide everybody by -4. Or as, well, you get a -4 and you get a -4. Because everybody needs to get one. The reason we need everybody to have one is because now -4 and -4 cancel out to just be a 1. So we're going to get our 1y equals -12x divided by -4. What is -12x divided by -4? 3x. -12 divided by -4 gives us a +3. The negatives cancel out. 12 divided by 4 is 3. You can also put those entirely into the calculator, not with the x, just the numbers. And then we have 24 divided by 4. Or 24 divided by -4, excuse me. What is 24 divided by -4? -6. So now we have our y all by itself. What's my m? M is always going to be the number multiplied against our x. So since we have 3x, our m is going to be 3. So our slope is 3. What's our b? -6. That's that y-intercept. Our b is -6. That's this guy over here. So this guy is our y-intercept. You can either put it as our b equals -6, and that tells us our y-intercept. You could put this as your point, 0, -6. When we just ask you for m and b, I'm not going to be picky about it. It needs to be a point. But if I just say, what's the y-intercept, I do want you to put it as a point. But I think for most of these, we just say, what's b? Okay, questions on this first one? Please do.
Well, before we did the problem, I thought this is what you wanted us to do. So instead of having to like just cancel out both sides, because it ended up like this anyways, can I just start like this?
Only problem is your signs are different. Because this is a -12x, and you have it as a +12x.
Yeah.
Okay, so that's the only problem with doing it that way. Good question, though, Elliot. Okay, we're going to try this again. We got a couple more to do on here. So we want to put them into slope-intercept form. We're going to find our slope and our y-intercept. They just have blanks for m and b, so we're just going to put them there. I've got -2x plus y equals 8. And we want to get this into slope-intercept form. So I'm just going to write the slope-intercept form up here. I know you guys have it up higher on your page where you can see it. But I like to have it up here. What do I need to do with A to get to my slope-intercept form? What's my first step going to be? Over here. What do we need to do? We need to do something with the 2x, right? Because our whole goal is going to be to get our y by itself. If I want him by himself, what do I need to do with that negative 2x? Add it. If I add 2x to both sides of my equal sign, this guy and this guy are going to cancel out. We're going to wind up with 0 x's on the left. That's my goal. I want 0 x's on the side that has my y. So we're going to have our y equals, I'm going to write it this way first, because a lot of times we won't think it. I'm going to just put it like this, 8 plus 2x. That's fine. But it's not quite slope-intercept form. It's kind of flip-flopped on us. Because what is my m? What's my slope? Remember, m is always with our x. It's the 2. So the danger of just, plussing our 2x on the end is that we might accidentally flip-flop them. Our m, our slope, is going to be the 2. Which means what's our b? What's our intercept? The 8. So when we have this in slope-intercept form, I want to kind of flip-flop those two pieces. And it doesn't matter what order we add things in. Just like 2 plus 3 is the exact same as 3 plus 2. 2 plus 4 is the same thing as 4 plus 2. It doesn't matter what order we add them in. So if you do write it like this at some point, and you go, oh, wait a second, my slope's on the wrong freaking side, we can flip-flop them. All right, 2x plus 8. If it's a plus, easy peasy, lemon squeezy, no problems. If it's a minus, we got to be super duper careful. Okay, so just be really, really, really careful because the signs don't get to change. This is our slope-intercept form right here. I have my y equals, then we have our mx, then we have our b. And so we're into our slope-intercept form. That's our slope. There's our intercept. We're done. So then let's look at the one on the right. We've got our 4x minus 2y equals 16. And we want to be able to put this into slope-intercept form. What do we need to do first? I want my y to be all by itself. Say it a little louder. Subtract 4x. Exactly right. Exactly right. Let's get that 4x to the other side of the equal sign. I want him to stay. Everybody else has got to go. Can't stay here. Gotta go home. So, whoa, let's help if I use a pen. I'm going to minus 4x from this side because I really need you to get away from y. You two are problematic together. Go away. So we're going to minus 4x from both sides. These guys are going to go away. That's the whole point of it. But we're still left with our minus 2y equals, and I'm going to remember this time that I usually like to have my x's in the front so that we get our mx. So I'm going to put my minus 4x. But then with that 16, that's a positive 16. It's not multiplied against it, so I'm just putting its own little plus in here, plus 16. We can do that. It's totally fine to rewrite our positive 16 as plus 16. Just don't have it be minus 4x times 16. That is different. And again, you don't have to do this and squish it in front, but then at the very end, you wouldn't have to do a flip-flop like this. And it's better. We're closer to slope-intercept form. I've got just y's on the left-hand side, but I don't have one y. I have negative 2 y's, which is an extra. What do I need to do to get my y by itself? Divide. By what? Negative 2. So this side gets divided by negative 2. And again, you could do it. Divide this whole side by negative 2. If this works for your brain, do it like this. But for a lot of people, it's going to be easier to get it right if I divide this by -2 and this by -2. If we think them as two separate pieces, a lot of people this works better, but there's a good chunk of people that we can do it as one fraction. It is totally okay. Either way is fine. I feel like this way is a little bit easier if we forgot. And that's okay. We're allowed to forget stuff. We are not perfect computers because we are not robots. So the whole point of this is that these -2's are going to cancel out and be just a 1. So the whole point of this is so that we just get 1y. So our -2 divided by -2 just gives us 1. So we're down to our 1y. If it helps you, you can absolutely put the 1 here. It doesn't make any difference. But if it helps you, do it. Then we're getting into our simplification on the right-hand side. We've got -4x divided by -2. What do we get when we divide -4x by -2? What is -4 divided by -2? Careful, yeah, the negatives are going to cancel out. The negatives are going to cancel out, so it's really just 4 divided by 2. Just 2. So we're going to have our 2 with the x. So when you're simplifying these numbers, think about them without the x. -4 divided by -2. When in doubt, type it in the calculator. Valid tool to use. What about our 16 divided by -2? What do we get on that one? -8, good. If it confuses you to switch to that plus sign, you can put it as plus -8. That works for me. That's totally fine. It's not the best math grammar to put plus -8 because we've got those two signs. Plus -8 is the exact same thing as if we minus 8. But if you use that as kind of like a middle step, it's totally fine. Means the same thing. So now I have my y all by itself. It's just y equals, everything over here is as simplified as I can get. So that's our answer. That's our slope-intercept form. This is the whole thing of what we're looking for. Our last step is to figure out our m and our b. Super duper close. Careful, because m is the number with the x. So what is the m? It's not the x is not included in the m. So our m is actually just the 2. Our slope is just the 2. It comes with the x, so I get why we think that, like, 100% I'm with us on where that process came from. Because it's with the x, so we're just like, yeah, that's mx. But this is mx. This is just m. Okay? I was like, at this point, I'm not going to be super duper petty about it, but when we get into formulas that we're working with later on, it's going to make a huge difference if we put a random x inside in a formula that we're working with. So we're going to work with some stuff that's later on that's going to be really important that we know that the number in front of the letter is the guy we're looking at. So if we know that our m is 2, what's our b? -8. This guy's our b. This is our y-intercept. Our y-intercept would be at -8. Okay? Questions on these two? We go and practice a couple more. Because this is a really important skill for us to have, and it's something we struggle with a little bit. And that's okay. You don't always have to be perfect at everything right away. Like, that's the point of being human, is learning and growing. So don't expect perfection of yourself from the start, because then you don't get to grow and be a human. Otherwise, we just be robots. So let's do 2 more. So this is at the top of page 7. You have these two. We've got 3x plus 4y equals 12. What are we going to do first? trying to get to where y equals mx plus b. That's our goal. Our whole goal is to get y by itself. What do we need to do? Subtract the 3x. I need that 3x to go to the other side of the dang equal sign. Those two don't get to work together. They cause problems. You never know anybody like that. Or if they work with a specific friend, they cause some chaos. No, we don't know anybody like that. So I gotta keep my x and y separated. They cause problems together. They chat, they're off topic, they just causing problems. So they have to be separated. Oh my gosh. So I need the 3x to go to the other side of that equal sign, other side of the room. They don't get to work together. So then we're left with our 4y. These guys cancel out. We're left with a positive 4y. So we can drop the plus sign. We don't have to keep it there. If it helps you, leave it there. Totally fine. You can put plus 4y. Doesn't change anything. It's kind of like putting a 1. Doesn't really change much. And then we have our 12 and our minus 3x. Well, I can't really combine those together. They don't have the same terms. So I'm just going to smush them together. I'm going to have my minus 3x and my positive 12. I just like to squish that 3x in front so that we have our mx kind of pre-set up for us, that they're going to be in the front. If you put 12 minus 3x, that is totally okay. But before the end, you'd have to switch them to have your x's in the front. What is our next step going to be? What do we need to do next? We need to divide by 4, because then I will get my 1y all by itself over here. But if I'm going to divide one side by 4, I have to do the same thing to the other side. So this guy gets divided by 4, and this guy gets divided by 4. Everybody gets to come to the divide by 4 party. Ooh, divide by 4 party. So we're left with just our y on this side. That's what we wanted. What is negative 3x divided by 4? Does that simplify?
Negative 3 over 4.
Yeah, negative 3 over 4x. So negative 3/4 x. You can write it like this. You could keep your x in the numerator with the minus 3 like we had above. But if we notice that it's actually negative 3/4 x, that is going to make things easier for us. It doesn't matter if I multiply the x on top of the 3 or if I multiply it next to the whole fraction. We can have fractions. Rise over run. We've done it with fractions. What do we get next to it? What do we have with our 12 divided by 4? 3. Whew, that one's not a fraction. Thank goodness. So what's our m? What's our slope? Down 3 over 4. So it's our negative 3/4. That's our slope. We would go down 3, right 4. Or up 3, left 4. Also would work. What's our intercept? 3. Okay. Now that we've done several of these, how are we feeling? Questions? Got one more to go. We're checking in. Got 7 minutes and one more of these to do. We're in a good place. This is our last one. So give it a shot. Take a minute. Try it. See what we can come up with. You don't have to do the whole thing, but try. Take 1 minute and see what we can do. Start this one. how do we start?
And
Almost add. There's a sense. Add 5. Just like this. Add 5. What did I forget? I just want to take the 5. I want to take the 5x. Gotta take everybody with it. The whole chunk. I need that whole chunk to leave. X and Y don't get to work together. They're that really chatty group of friends that sit to the side and they won't ever stop talking during class. Separate it. Gotta get them away from each other. X and Y don't get to sit on the same team. They're driving me nuts. So I gotta separate them. So I gotta take my 5x, the whole 5x, and put it over here. Because I don't want them to work together. They're causing problems. So these guys cancel out. That's the whole point of this, is for them to go away on this side. So then we're going to have our 7y equals our 9 plus 5x. I tend to put it as our 5x plus 9. Because we like to have our mx in the front. So if we have a piece with an x, I'm going to squish it in the front. You don't have to have it right that. If you have 9 plus 5x, that's totally fine. By the end, you're going to have to switch it around. What do we do next? Divide by 7. So this guy divides by 7, because that gives us our 1y. That's our whole goal. Which means this guy needs to divide by 7, and this guy needs to divide by 7. Everybody gets to come to the divide by 7 party. So that gives me that my y equals, does 5x divided by 7 simplify? Not really. But I can rewrite it as 5/7 x. That works for me. Does 9 divided by 7 simplify? Bless you. Does 9 divide by 7 nicely? Or is it unpleasant and decimally? Unpleasant and decimally. We're going to leave it as a fraction because that is gross. And luckily, we're not graphing that one, so we don't got to worry about the fact that it is fractionapalooza. Last thing we got to do is tell me which one is m, the 5/7. Which one is b, our 9/7. Okay, so identifying these pieces is really important. Tomorrow we'll finish out page 7 with that point slope form and looking at that. So I'm going to give you guys homework number 3, which includes the stuff we did today, the stuff we're going to do tomorrow, and some like review stuff. So make sure that you're doing the Canvas assignments. Those are still up there and popping up every week. We're going to have, this one's homework 3. It's due technically on Friday. And we're going to do a skills check on Friday, just to kind of check in with how we're doing this chapter. Okay, so I'm going to pass these now. Did you have a question?
what is the break?
23 more school days until fall break. That, I keep that countdown up 2 days every day. All right, so here's homework 3. I'm so good at counting. Notice how I tweaked out that even for 1 second. Not even one. Here's this. Okay, so we're going to do a skills check on Friday. I just try and give you warning when I can.
We take the test, right?
Test retake policy, purple page. You have to do corrections on it first. There is something sticky on my shoe. Yeah, you have to do corrections on it first, but yes, you can retake tests.
I'm too short. I can't see that. I'm too small. Yes. I'm 4'11". I can't see that. You don't understand my pain. Yeah. I'm short. I'm short.
Yeah, I know.
My But I am gonna hit 6.5 by the time this year is over.